This is the beginning of our TK Academy course, where the T and the K stand for Team Knowledge for architects and designers. This is a specialty course over the design of sensitive compartmented information facilities, also known as SCIFs. SCIFs are unique spaces, but they are also common within the intelligence and military communities. In this course, we are going to explain what a SCIF is and what is the purpose that they serve. We'll explain what the concept of security in depth means and how it applies to the planning and placement of a SCIF. We'll identify the different sound groups which are applicable to SCIF design and what the acoustical performance ratings are for built components. Finally, we'll identify the key features in door and windows that are placed within a SCIF. What is a SCIF? A SCIF is an area, room, or building that is used to contain and protect classified information, which includes sensitive compartmented information, also referred to as SCI. SCI pertains to or is derived from sensitive intelligence sources, methods, or analytical processes. To protect SCI, it can only be stored, used, handled, processed, or discussed within an accredited SCIF to limit exposure to unauthorized or incidental access. Access to a SCIF is strictly controlled and limited to individuals with the appropriate security clearances. When is a SCIF needed? SCIFs are established when there is a clear requirement for access to classified information that is crucial to the mission or operations. A SCIF must be accredited for use. Accreditation is a formal approval that the SCIF meets the prescribed physical, technical, and operational standards. If a SCIF cannot be accredited, it cannot be used. There are 6 classifications to SCIFs. However, a SCIF may qualify as more than one and may be a combination of classification types. The first classification is a secure working area, which is an area where SCI is handled, discussed, and/or processed, but is not stored on a permanent basis. Next is a temporary secure working area, which is similar except this working area is used less than 40 hours per month. There may be a temporary SCIF, where a SCIF is needed based upon a limited time to meet tactical, emergency, or immediate operational requirements. Open storage is a SCIF where SCI is openly stored and processed. Closed storage is where SCI may be used, but it is not stored unless it is within a GSA-approved storage container. The final classification is continuous operations, where a SCIF is staffed and operated 24 hours a day, 7 days a week. Another term that is sometimes used for a similar type of facility is SAP-F. A SAP-F and a SCIF are very similar, so what is the difference between the two? A SCIF stands for Sensitive Compartmented Information Facility and is primarily used by government intelligence communities such as the National Security Agency, the Central Intelligence Agency, and Department of Homeland Security. SAP-F stands for Special Access Program Facility and is used mostly by the military. There are slight differences in the accreditation process, but since 2016, both reference the ICD 705 technical specifications for the regulation of design and construction. As one could imagine, there are multiple policies and regulations governing SCIFs. Most of these come from the intelligence community, although the Department of Defense has also contributed to the regulations of the operations of SCIFs. The ICD 705 technical specifications for construction and management of sensitive compartmented information facilities has become the basic guide for governing design and construction of SCIFs. However, DoD has also developed a United Facilities Criteria, UFC 4-10-5, for the planning, design, and construction of SCIFs. These two regulations are very similar, but there do exist minor differences to be aware of. Another source of influence on a SCIF, especially in facilities outside the United States, is the Security Environmental Threat List, or SETL. The SETL is prepared semi-annually by the Department of State. It identifies potential threats of international terrorism against the United States and rates the threat potential as critical, high, medium, or low. The details for determination of the threat category are classified information and are not shared with the project development team. However, the team must be made aware of the resultant mitigation measures, which are likely to become project requirements. Not all SCIFs are the same. There is not one size that fits all. There may be different project requirements for the accreditation official to consider. Factors such as the classification of the SCIF based upon what type of information is being handled within the space, the physical location of the SCIF, the perceived threat and identified vulnerabilities, security in depth, which is the physical layers of security surrounding a SCIF location, the type and the amount of classified information that is being processed within the SCIF, and if classified information is being permanently stored within the SCIF. Are there equipment or networks that will process national security information? Also, what are the project costs and what are the total risk to that project? Security in depth is an important concept in the protection of a SCIF and the information contained within. Security in depth is a multi-layer approach of physical security measures that surround a location to create layered defense against potential threats. Each layer is another opportunity to delay and detect potential threats trying to infiltrate the SCIF. The presence of existing security in depth may greatly reduce the physical security measures and the construction cost associated with a SCIF project. There are means to achieve security in depth, such as locating a SCIF on a military installation or other secure compound that has a dedicated response force, locating a SCIF within a building or fence compound that has established access control, or locating a SCIF in an office area that is surrounded by other spaces that are controlled and protected by an intrusion protection system. Tempest is the term for the management and control of electrical emanations from communication and digital technologies that can be unintentionally transmitted and used to collect information from unauthorized sources. A physical connection of conductive materials is not necessary to transmit electrical emanations. Tempest can also be used in non-electrical sources such as photonics and acoustics. An entire system must be designed and certified to Tempest countermeasures, not just individual components. Tempest controls are concerned with both incoming radio frequency interference, or RFI, and outgoing transmission interceptions that may contain sensitive or classified information. There are 4 techniques that can be implemented to protect equipment and networks from Tempest threats: distancing, shielding, filtering, and masking. Security of the construction site for a SCIF is of the utmost importance. Work on a SCIF may only be performed by a U.S. person, which means a U.S. citizen or lawful permanent resident, also known as a green card holder. The project may require access control of construction materials and personnel to the construction site. Construction materials and tools may require inspection prior to being allowed on a construction site. Construction workers may not be permitted to bring phones, radios, or other communication devices onto the construction site. Additional security measures will have a significant cost impact on the project, so they should be determined during the project planning phase. A construction security plan is a written plan developed by the site security manager that lays out the procedures and controls for securing materials, personnel, and the site for the entire project from planning through construction. The construction security plan should identify security in depth, key project adjacencies in terms of facilities, activities, and groups, document control, procurement, shipping, and storage of materials, site security, and access for construction workers. The accreditation official is responsible for the review and approval of the construction security plan. The project team is responsible for developing and maintaining a photographic construction surveillance record of how the SCIF was constructed. The photographic report documentation should be developed congruent with the construction progress to document various stages of construction. Particular attention should be given to the wall construction and cavity space, penetrations through a wall, the top of wall connections, and metal duct construction. The photographic documentation is used to validate that no unauthorized equipment or devices have been placed within the concealed areas that are not visible within the finished space. This is the only authorized use of a camera on the construction site of a SCIF. In addition to construction security, the team must also take steps to protect information regarding a SCIF project. It is not permissible to identify a SCIF location on the planning, design, or construction documents. Areas may be identified as secure area or controlled area. Photos of SCIFs, either completed or under construction, are strictly prohibited. Should the project require a building permit, the permit drawings should not be posted or made public through the building department's website, portal, or subscription services. General contractors should exercise document control in their bidding and procurement of subcontractor services. The SCIF accreditation is a very important step that a SCIF must receive before it can be utilized. The accreditation is done by the accreditation official or their designee. This process includes review of all documentation related to the planning, design, construction, and operation of the SCIF. The site security manager assembles all its information and submits it to the accreditation official for review. During programming and planning, crucial decisions must be made that determine the success of a SCIF project. Is the SCIF an entire facility, an area within a building, or just a single room? Will there be more than one SCIF, and if so, how many? What is going to be the SCIF classification? Will the SCIF have a secure vestibule, and will there be staff monitoring the SCIF entrance? Will the SCIF perimeter be standard, enhanced with RF shielding and wire security mesh, or vault construction? What is the required sound attenuation rating at the SCIF perimeter? Are there compartmented areas within each SCIF, and if so, how many? Will there be equipment or networks that will be processing national security information that will result in tempest mitigation measures? The existing security requirements of the physical space must be considered in SCIF planning. Considerations that will affect design and construction are the sound ratings of the perimeter and if tempest countermeasures are required. Will there be areas that are designated as non-discussion zones, such as stairwells, vestibules, storage areas, and restrooms? What areas will have amplified discussions with the use of speakerphones and video conferencing? Which areas will have non-amplified discussion, such as normal office working areas? Will everyone who works within the SCIF have equal access to secure equipment? Equipment that will be on public channels or networks must meet minimum distancing requirements, such as a standard telephone must be kept at a minimum of 18 inches away from a secure telephone. If a facility has multiple users or tenants that each require secure space, it is best to plan for consolidation of these groups together within a single SCIF area or boundary. Individual areas can be compartmentalized within a SCIF boundary, and consolidation of spaces will reduce the accreditation requirements, construction cost, and maintenance. SCIFs typically require annual inspections to retain accreditation, and the process is simplified when critical secure components are co-located within a consolidated area. This does create additional effort for design and planning when there's more than one tenant within a SCIF, and there are additional operational controls that need to be implemented to ensure the privacy of information. Construction of the secure perimeter is the primary concern during the design of a SCIF. The SCIF perimeter needs to include mitigation measures against forced entry, covert entry, video surveillance, acoustical eavesdropping, and electronic emanations. Design should take a six-sided approach, which means that security features must be equally applied to all four walls, the ceiling, and the floor. All six sides must meet the same security and performance requirements. The SCIF perimeter walls must be permanently and solidly constructed to the existing structure and to one another. Walls must extend from the true floor up to the true ceiling. If there are concealed spaces, such as beneath a raised access floor or above in a ceiling plenum, the walls must fully extend through that space to the structure above or below. Wall joints must be sealed at the perimeter edges, and penetrations must be sealed with acoustical sealant on both sides of the wall. Ducts that are passing through a perimeter wall will have flexible connections installed on the secure side within 6 inches of the wall to mitigate the transfer of sound from the space. The perimeter must not only be able to meet the security requirements for SCIF accreditation, but it must also be routinely inspected for continuous compliance and visual verification and no surreptitious penetration such as video or audio probes. Visual inspections will be particularly concerned with the top-of-wall condition, penetrations, and the interior of sizable air ducts. It is imperative to provide access to the entire perimeter wall for regular visual inspections. This includes access to normally concealed areas, such as the portion of the wall that is above the ceiling. The SCIF perimeter must also include intrusion detection systems or alarms. is especially critical when a skiff is adjacent to public areas or on the first floor of a building. Interior areas of a skiff to which reasonable access could be gained, including windows and common walls, shall be protected by an intrusion detection system. Skiff walls, doors, and partitions will have minimum sound attenuation requirements. The acoustic performance requirements are intended to keep information secure from being overheard by someone who is passing by or standing next to a skiff. The ICD 705 identifies two sound groups that are used for skiff construction. Sound Group 3 applies to interior partitions that define compartmented areas internal to a skiff. Sound Group 4 applies to perimeter walls, areas which have multiple occupants or users, such as in a shared open office work area, and spaces where amplified audio may be used, such as a video conference room. Sound Group 3 is to be designed to a Sound Transmission Class, or STC, of 45 or higher. Within this type of assembly, loud speech can be faintly heard but not understandable, while normal speech is unintelligible. This is typical of office spaces where secure information is being handled or processed by individuals. Sound Group 4 has a higher acoustic rating with an STC of 50 or better. Assemblies built to this level will mask very large sounds, such as singing, musical instruments, or radio at full volume. Sounds can be faintly heard or not at all. This sound group is typical of spaces with multiple occupants and is often used for conference areas where amplified audio is used. The sound group ratings are used to establish minimum performance requirements. The sound group ratings apply to doors, windows, piping, duct, and electrical penetrations for all 6 sides of the skiff perimeter enclosure. When typical sound transmission mitigation measures are inadequate for compliance with acoustic performance requirements of Sound Groups 3 and 4, then sound masking systems may be utilized. We'll take a quick break to answer some trivia. True or false? Recessed and semi-recessed fire extinguisher cabinets are prohibited on the perimeter wall of a skiff. The answer is true. A recessed fire extinguisher cabinet will penetrate the wall, therefore violating the integrity of the perimeter wall and compromising the physical security, acoustics, and in some cases the RF barrier protection. This is not a requirement indicated in the ICD 705. However, it is stated in the UFC for military projects. The point of this trivia is to know the applicable criteria for the skiff that is being designed and built. As we resume the course, we will use this break as an opportunity to introduce the workings of a Faraday cage. A Faraday cage is an enclosure of conductive metal, such as wire mesh or metal plates, that cancels out electromagnetic fields. When an electromagnetic charge strikes the enclosure, the flow of electrons around the enclosure creates a second electromagnetic field in the opposite direction. The superposition of these two fields cancels and creates a net electrical charge of 0. Therefore, the object within the enclosure is not affected by the external electric fields. For a Faraday cage to be effective, it must be electrically grounded to allow the absorbed energy to dissipate safely from the enclosure structure. This phenomenon was first observed by Benjamin Franklin, but it was Michael Faraday in 1836 that observed an electric charge only existed on the exterior of an enclosure made of conductive material, and that the charge had no effect on anything within the interior. To test this observation and to prove his hypothesis, he built a room coated with metal foil and used an electrostatic generator to strike the room with high voltage discharges. He placed an electroscope within the room to prove that there was no electrical charge present on the interior. What does a Faraday cage have to do with skiffs? Radio frequencies are a form of electromagnetic waves. They are often used to create interference within a skiff. Radio frequency interference can be blocked from a skiff by applying the principles of a Faraday cage. This is accomplished by providing continuous conductive material, usually an RF foil product, that is applied to all 6 sides of a skiff. The RF foil is usually placed between 2 layers of gypsum wallboard for protection and concealment. The key is that the shielding must be continuous without any interruptions and must be independently grounded, separate from the building structure and electrical grounding systems. Doorways into a skiff must be secured. Vestibules are very effective for maintaining visual and acoustical security into a skiff. When possible, there should be a single point of entry for entering and leaving. Skiff doors can be the typical thickness of 1 3/4 inches and can be made of metal or wood. Wood doors must be solid wood stave construction. Metal doors must be heavy-duty construction with a minimum 18 gauge thickness for the surface faces. Skiff doors must also include automatic closures that are installed on the interior side of the skiff to resist tampering. Doors must have the same acoustical performance as the skiff perimeter. Acoustical seals must be installed on the door frame, and an automatic door drop bottom must be included to create the acoustical seal around the door edges when closed and seated within the frame. Metallic gaskets are used for seals when there is an RF shielding requirement to ensure electrical continuity through the door and frame when the door is closed. The type of door hinges and door mounting should be based upon the manufacturer's recommendations for the door performance. The hinges may be lift hinges that are directly tied to the function of the drop bottom sound seal. The door hinge pins are to be tamper resistant. Tamper resistant hinges shall have non-removable pins, security pins, set screws, welded or equipped with a safety stud. A skiff should have a single primary access point. That access should be designed with a secure vestibule when possible. This will prevent visual observation into the secure space and will enhance acoustic protection and physical security. The primary skiff door must be equipped with an X10 high security digital combination lock meeting federal specifications. The doorway into a skiff should also be equipped with an access control system, so only authorized individuals are permitted. Typical means of access control are electronic keypads, card readers, or even biometric readers such as fingerprint scanners. Electronic access control systems will maintain a historic entry log of all individuals who enter the skiff. Even being a secure space, a skiff still needs to meet egress and life safety requirements. On larger sized skiffs with an occupancy of 50 or more, a second doorway for emergency egress will be required. When this occurs, the egress door will need to meet the same physical security and acoustical performance requirements for a skiff door. In addition, egress doors will have no external hardware so that there can be no unauthorized entry or a second point of entry into the secure space. The door should be secured with panic hardware, and it is recommended that the door has a delayed egress action compliant with NFPA 101. The egress door must be alarmed and provide local annunciation within the skiff for when the door is open. In keeping with a security in-depth approach, skiffs are always best located internal to a building and away from external walls and windows. Exterior windows are not recommended within a skiff, but they are allowed. If exterior windows are provided, they must meet the following. Windows have to be fixed and non-operable. Windows still need to comply with the acoustic performance requirements of the perimeter. They must provide mitigation of visual surveillance, such as the use of one-way glass or pull-down shades. Windows must include intrusion detection alarms when they are less than 18 feet high from the adjacent ground surface. And when tempest countermeasures apply, an RF barrier film must be applied to the interior glass surface. Air ducts that are penetrating the skiff perimeter must have a Z-bend on the secure side. The air ducts themselves should have an acoustic lining or be fabricated as a double-wall acoustic duct to reduce the transmittance of sound. Ducts shall have a flexible connector on the secure side within 6 inches of the wall penetration. This is to minimize the sound transfer, but also to act as a dielectric break between the conductive metal materials of the ducts. Large ducts shall have an access port on the secure side for visual inspections of the inside of the duct. Duct penetrations that are greater than 96 square inches are required to have security bars installed within the duct in line with the wall penetration to maintain physical security. Waveguide panels are installed within air ducts to allow the airflow while shielding from electromagnetic energy. These are required on skiffs when tempest countermeasures and RF shielding apply. They comprise of three-dimensional apertures, typically in a honeycomb-shaped arrangement, that function as a filter for electromagnetic waves. They are made of metal, which maintains the conductive continuity of the perimeter of the RF shielding. When piping penetrates a skiff perimeter, dielectric brakes are installed within the piping runs to interrupt the electrical pathway congruent with metal piping. These are installed on the secure side of the skiff within 6 inches of the wall penetration. The dielectric brake is made of non-conductive material, which breaks the continuity of metallic piping and the electric pathway along the pipe. There should be no electrically conductive material bridging the break or gap, such as RF foil that would overlap the connection, or a grounding wire which would connect the two sides of the break. In cases where piping cannot have a break, such as with fire suppression lines, grounding the pipe may be an alternate means used to protect the conveyance of electromagnetic energy and emanations. Communication and IT systems are crucial components of modern-day skiffs and are often the most vulnerable to infiltration and compromise. There are physical measures that can be implemented in a skiff design and construction to protect these vital systems. A communication server room should be located fully within the skiff perimeter to make it part of the secure and protected environment. The server room should be adequately sized so that it will be a minimum of 20 inches between equipment of different classifications, such as secure and non-secure systems. This distance between equipment may increase to 36 inches in certain security conditions. Both secure and non-secure network cables are permitted to coexist within the same cable tray for distribution, but must maintain a minimum separation distance of 2 inches. When the cables run longer than 100 feet, the minimum cable separation distance increases to 6 inches between them. In many cases, there may be dedicated cable trays for each classification network cabling. There are 3 typical network systems employed within a skiff. Non-Secure Internet Protocol Router, or NIPR, is referred to as the Black Communication System. The Secure Internet Protocol System, or SIPR, is referred to as the Red Communications. The third that is less common is the Joint Worldwide Intelligence Communication System, also known as JWICS. Skiffs will require both primary and secondary power systems. If tempest mitigation measures apply, the electrical power will require power line filters to be installed which block emanations from being transmitted through the power cables. Security must be maintained during a power outage, so backup power is required for the electronic security systems at a minimum. Backup power should be maintained for at least 24 hours, and batteries are typically adequate for most electronic security systems to function for that length of time. Most skiffs handle, process, and store information digitally and cannot risk the potential of losing data when power is lost, so uninterrupted power supplies, or UPSs, are often provided to bridge between the primary and secondary power systems. It is common for emergency generators to be associated with skiffs, but a skiff does not require a generator. It is the mission that dictates the requirement of a generator, not the facility. This brings us to our conclusion of this TK Academy course over skiff design. If you enjoyed this course, please give it a thumbs up and leave us a comment. Also, remember to subscribe to our YouTube channel for more videos like this one and other video content from TK Architecture.